Hello everyone, my name is Dong Fan and our topic is about data visualization and modeling for the physical property of different quality wines. Our members is me and Jia Liu and Jing Cao. The supervisor is Professor Mao Lin Huang. And our presentation will divide the 5 parts as followed. And the first part is about background and significance. With the improvement of living standards, people pay attention to enjoying life. One is a symbol of quality of life and is popular among the public. The wine industry is growing rapidly and the wineries are highly competitive. How a winery stand out from the crowd is a question worth study. However, there are no standard wine quality assessment standards and methods in the industry. It can only be judged by expert opinions and is easily influenced by external influences. This is very inaccurate. There are two significance on this topic. One is that the quality of the wine is used in many business models, including wine producers and wine assessment agencies. The other is that there is no uniform industry standards to measure the quality of wine, and there is no easy way to assess the quality of wine. The second part is about the impact of data visualization. Data visualization plays an important role in data analysis. There are many visualization methods, such as bar chart, pie chart, and so on. By separating the lines, height, or area of the same type of graphic, the content of the different parameters can be clearly described. This approach allows the observer to compare different attributes and easily understand the overall distribution of the data. The impact divided in 4 parts. Firstly is faster transmission speed. The human brain processes visual information 10 times more than written information blocks. Using charts to aggregate complex data ensures a faster understanding of relationships than confusing reports or spreadsheets. Second is multidimensionality of data display. Under visual analysis, data sorts, combines, and displays value for each dimension so that you can see multiple attributes or variables that represent object or event data. Third is display information more intuitively. Big data visualization reports enable us to present complex information in even short graphics or even individual graphics. Decision makers can easily interpret a variety of different data sources. Fourth is the limitation of brain memory ability. In fact, when we look at objectives, our brains have long-term memory and short-term memory, just like computers. Only when we let us write down the items and after a short memory can they enter long-term memory. In the case of wine industry, the processing of wine quality data through data visualization technology can effectively improve the production efficiency of wine making and reduce product costs. In the process of visualizing the dataset, we sorted the quality of the wine based on the amount of different chemical elements in the wine. This will not only help the winery to improve the quality of the wine, but also reduce the production cost of the wine, improve the market and increase its competitiveness in the market. Okay, next I will pass to the Jialiu to introduce the data visualization by Tableau and Power BI.
In this section, I will introduce the data visualization by Tableau and Power BI. In this table shows the dataset of wine quality. From this table, we could find out there have 20 important attributes. We suspect that there is a direct relationship between the content of those elements and the quality of the wine. The entered dataset has no more than 600 rows, including 1,600 red wine items, as well as 4,900 items of the white wine. Those data sets are judged by more than 3 experts, which reduce the error. In addition, the attributes in the dataset have no missing values, which reduce the impact on accuracy and make sure the accuracy of the final conclusion. Our group used the Tableau to build 4 worksheets and a dashboard to evaluate the quality of red wine. The visualization graph can make readers easier to understand and also shows directly the relationship between the different attributes and the quality of those wine. The quality of 8 represents the highest quality of red wine. The value 3 represents the lowest quality of red wine. Figure 1 and Figure 2 shows the relationship between the average value of different elements and different levels of red wine quality. Those two bar charts can clearly compare which elements have a high population in the same level of red wine. The Figure 3 shows the average of different elements of each wine's quality level. From the picture, you can compare which element of the same red wine level contains more. At the same time, you can quickly and clearly compare the content of the same elements in different wine levels. The crosstab in Figure 4 is based on the data from Figure 5, shows the detailed average value of each quality dataset. Figure 5 contains all of about worksheets, which makes the stakeholders to observe the change with different elements, as well as helps them filter useful data to improving the quality of red wine. We use Power BI to analyze the relationship between chemical elements and quality in the white wine quality assignment section. Figure 6 shows the changes in the main elements of different white wines at different quality levels. From this figure, we clearly find out that no matter which quality levels, the citric acid content is the highest in white wine. The content of chloride is the least in white wine. Figure 7 shows that the tendency in the minor elements of various red wine at different quality levels. From Figure 7, we could see the sulfur content is basically similar within the quality range from 3 to 9, when the quality of white wine is the worst. The total sulfur dexical content is the highest. In Figure 8, is combined with two pie charts. One is the highest quality, another one is the lowest quality. The two figures show the population of chemical elements in quality 3 and 9. The stakeholders can easily master the changes in the overall data set. In conclusion, when the value of quality is 9, the residual sugar content is the least. The winner can use the analysis of data results to evaluate wine levels. This way is much simple and objective.
In the section of research methods and processes, after the analysis and evaluation about multiple data mining tools in our group meeting, we determined to apply the 9 workflow to forecast the quality score of various types of wines for the wineries as well as wine rating institution through 3 kinds of classification techniques, such as the decision tree model, K-nearest-neighbor model, and random forest model. The decision tree classifier is a multi-classification model used for decision-making in a tree structure. Furthermore, the root node represents the collection of all data from the dataset. Each internal node serves as a test and judgment condition for the target attribute, and all the eligible data are included in the final category, that also known as the leaf node. The K-nearest-neighbor model adopts the method about measuring the distance between different eigenvalues to classify. K means the number of neighbors defined externally. Furthermore, the category and characters of the single sample are the same as most of K-nearest neighbors in the feature space. The random forest model consists of a certain amount of decision trees that are unrelated to each other. When a new input sample is entered to the classifier, each decision tree in the forest determines the category to which the sample belongs. In the end, the sample is predicted to be the most frequently selected category. There are 4 stages in the process of implement. Firstly, is connect each required node appropriately. Secondly, is configure parameters. Thirdly, is the required analysis. Finally, we select the most suitable classifier for our case for protecting one quality score. The configuration of data pre-processing and transformations among these 3 classifiers are implemented by the same workflow, because the inputted one quantity training and testing datasets in each classification technique are identical to the others. The overall operational process of cleaning data in the 9 are shown in the Figure 10 and Figure 11. The specific methods of realization are as follows. Step 1. We add the statistic node to calculate the statistical moments of both training and testing dataset. The statistics views shows that there is no missing value. In the case of data inputted by another customer contain missing value that affect the accuracy as well as the success of the protection, we utilize the missing value column filter node and the missing value node for removing and modifying correlated values. The type of quantity attribute is an integer in the one quantity training dataset, since we add the number to string node to change the value types into a string for the forecasting stage. Step 4. The column filter node enables clients to choose certain columns about physical chemical components for the prediction phase. We bring the partitioning node to divide the inputted one quantity training set into 2 portions by 70% in the first part for the classifiers to learn, as well as 30% in the second part for evaluating the accuracy of the results, and select the random method of sampling. Furthermore, this setting can be changed according to the need of various managers or one experts. In terms of particular appropriate size of the first partition and required sampling method. The node connection map about the decision tree model in Nine workflow is illuminated in Figure 12. After testing different parameters multiple times in the decision tree learner node, we determine the most appropriate value in the dialog option of minimum number recalled pre-node as Figure 13, which bases on the accuracy result. As shown in Figure 14, our group used the default setting in the decision tree predictor node because we just need the classifier to forecast the quality score in this case. On the basis of above multiple experiments, when the value of minimum number recalled pre-node in the setting dialog is 7, we are able to acquire the highest accuracy rate in the square node is 59.375%. That shows in the Figure 15. The node connection map about k-nearest neighbor mode in Nine workflow is exhibited in Figure 16. After testing plenty of different parameters in the k-nearest neighbor node, based on the result of accuracy, we decide the most suitable value to 1 in the number of neighbors to consider items as Figure 17, because an odd number is beneficial to reduce the chance of ties. According to the above multiple types, when the value of number of neighbors to consider in the configuration dialog is 1, we can receive the highest accuracy rate in score node is 57.5%, which shows in Figure 18. This node connection map about random forest mode in Nine workflow is displayed in Figure 19. After the assessment of various parameters in the random forest learner node, we choose one of the most popular values of limited number of levels in the configuration dialog referred to the Figure 20, which bases on the accuracy result. As provided in Figure 21, we selected the option about appendant overall prediction confidence in the random forest predictor node, which enables us to check the maximum confidence values of each attribute separately. Based on the above many experiments, we are capable to reach the highest accuracy rate in the square node to 65.208%. That percent in the Figure 22, when the preset value of limited number of levels in the dialog options to 10. On the basis of the analysis and comparison of the 3 accuracy rate that's presented in the table, such as decision tree model, k-nearest neighbor model, and random forest model, for protecting the quality attribute of various types of wines. The random forest classifier obtains the highest accuracy than others, which is 65.208%. However, we also need to evaluate the advantage and disadvantage of each classifier and choose the prediction model that best fits our dataset, not just refer to the prediction accuracy. Therefore, based on the construct of above elements and filtering the redundant columns, as well as measuring the correlation of selected column in our dataset, we determine the random forest technique as our final model in this report. In the conclusion section, on the basis of our research project, which consists of 2 main portions in terms of data visualization about physical-chemical properties and prediction model for the quality score in various ones. Above used business intelligence tools, such as Tableau and Power BI, enable winery managers through dashboards to real-time monitor and analyze changes, as well as trends in regard to the chemical composition of wines during the period of fermentation. The result of data visualization can assist wineries of all sizes to develop two standards about the chemical composition of wines to save cost and increase sales. For example, the average value and proportion of each chemical component in different quality wines. In addition, we utilize 9 workflow for modeling 3 classifiers in order to protect the quality attributes for each one, such as the decision tree, Kenner's neighbor, and random forest. Based on the 3 essential criteria in terms of the properties of input dataset, the accuracy of the predicted result, and the characters of the model, we have determined that the random forest is the most suitable model in this case. Overall, the random forest model provides more accuracy results than other methods, and maximally promotes wineries and wine rating agencies to establish an automated and objective wine scoring system by advanced technologies rather than only rely on traditional test assessment methods by wine experts. This is our references. Appreciate, thanks.